Probability. So before we start probability, we must study some theory related to it. Okay. Like experiment. Do you know the meaning of experiment? Anything which is performed is called an experiment. Okay. Write in your notebook. Anything which is performed is called an experiment. How many types of experiments are there? So remember, there are two types of experiments. Okay. First are the experiment which are well known to us and are called deterministic experiment. Okay. What?
Deterministic experiments.
Deterministic experiment. So one more thing, which is very important to understand the meaning of deterministic experiment is, you can write it in note, the meaning of outcome. Outcome or the outcomes. The result of an experiment. The different results related to an experiment are called the outcomes. Is that clear to you? So write in your notebook the different results related to an experiment. Are called outcomes. Okay. And now we come to our topic, deterministic experiment. The experiments whose outcomes are definite always. Is that clear to you? Deterministic experiments are the experiments whose outcomes are always definite. The experiments whose outcomes are always definite. That is, whenever we repeat the experiment, the outcomes are always the same. That is, whenever we perform the experiment, the results are always the same. Okay. For example, experiments of chemistry and physics. Do you know, if we pass carbon dioxide gas through calcium carbonate, what happens? What are the observations when carbon dioxide gas is passed through calcium carbonate? Do you know? Whenever carbon dioxide gas is passed through calcium carbonate, what happens then? What are the observations? I am asking only about the observations, not about the equation. Sorry, calcium hydroxide, lime water. Whenever carbon dioxide is passed through lime water, what happens? Wait, lime water is simply turbid.
It turns milky.
And it turns it milky. It turns the lime water milky. Again, whenever carbon dioxide gas is passed through lime water which is turbid, it changes from turbid to milky. And this experiment, whenever you repeat this experiment, you already know that it will turn the lime water milky. Is that clear to you? So these types of experiments are called deterministic experiment. Understood?
Yes, sir.
And the second type of experiments, these types of experiment, we are not going to discuss the deterministic experiment, but for the discussion of probability, we must know the deterministic experiments. Okay. So the second type of experiments are probabilistic experiments or the random experiments. Okay. Random experiments or probabilistic experiments. Okay. Random experiment or probabilistic experiment means what? They are just opposite to the deterministic experiment. In deterministic experiment, we can determine the result. We already know the result, as whenever they are performed, they always give the same result. Understood? But in random experiment, there are certain numbers of outcomes, and we don't know what will be the outcome definitely. Means they are always different. Understood? If two or more outcomes are related to an experiment, then that type of experiment is called random experiment. Understood? The experiment which can result in two or more, in one of the two or more than two experiments, we can say. Okay. The experiment which can result in one of the two or more than two, one out of two or more than two outcomes. For example, have you written the definition?
Yes, sir.
The experiment which results in two or more, we can say, possible outcomes. Okay, probable outcomes. The experiment which results in two or more than two, the experiment which results in two or more than two possible outcomes are called the random experiments or the probabilistic experiment or the probability. This is the probability. Understood? The outcomes which are related to two or more than two possible outcomes means only one of two or more than two outcomes can occur. For example, in throwing a die, experiment of throwing a die is a random experiment. We all know there are 6 outcomes related to it. Either it comes up with 1 or 2 or 3 or 4 or 5 or 6. Understood? Possible outcomes are 1 or 2 or 3 or 4 or 5 or 6. Okay. Throwing a die is a random experiment. Understood, everyone?
Yes, sir.
Yes, sir.
Yes.
Secondly, tossing a coin. Do you know before tossing what will be the result? What will be the outcome? Whenever you say either head or tail, it means you don't know the definite result. This is same as throwing a die. Throwing a die is also a random experiment in which it comes up either with 1 or 2 or 3 or 4 or 5 or 6. Means there may be 6, one of the 6 possible outcomes. Understood? Similarly, tossing a coin is also a random experiment. Understood, everyone? So, to explain it more, first we will discuss the approach of probability. What is the meaning of approach to probability? So remember, there are 2 approaches of probability. Write the next step. There are 2 approaches to probability. The first one is called, there are 2 approaches to probability. Number 1, classical approach. Classical approach. According to classical approach, the probability of occurrence of an event probability of occurrence of an event equals to number of favorable outcomes equals to the ratio of number of favorable outcomes. The ratio of number of favorable outcomes to the total number of possible outcomes. According to classical approach to probability, probability of occurrence of an event equals to number of favorable outcomes upon total number of possible outcomes. Okay, written, everyone?
Yes,
Yes,
sir.
sir.
For example, if we discuss the experiment of throwing a die, if the question is that find the probability of getting 2 in throwing a die. Find the probability of getting 2 in throwing a die. Means the favorable outcomes is getting 2. So number of favorable outcome is only 1. Understood? Number of favorable outcomes two. And total number of possible outcomes. How many total number of possible outcomes are there? Total number of possible outcomes equals to 6. Means 1 or 2 or 3 or 4 or 5 or 6. And possible outcomes is only 1. So we can find this probability P equals to, by using this formula, number of favorable outcomes 1. Total number of possible outcomes 6. So the probability will be 1 by 6. Understood?
Yes, sir.
Yes, sir.
So this classical approach we have studied in previous classes also. But when there are different types of events, which are called compound events, which are obtained by combining 2 or more than 2 simple events, then it is very difficult to use this classical approach. So we will study about other approach also, which is called axiomatic approach to probability. Okay. Axiomatic approach to probability. Axioms means the rules, and axiomatic approach to probability uses, actually it uses the theory of set. So it is very easy to represent the favorable outcomes and the total number of outcomes using set theory. Axiomatic approach to probability. The theory of probability, which is related to set theory. The theory of probability, which is related to set theory, is called axiomatic approach to probability. The theory of probability which is related to set theory is called axiomatic approach to probability. Written, everyone? Set theory. So before we discuss about the axiomatic approach, we must know about the different terms related to axiomatic approach to probability. Okay? Then only we can clearly understand the axiomatic approach to probability. Understood? So first write terms related to axiomatic approach to probability. Terms related to axiomatic approach. This is the theory which you have not studied in previous classes. Terms related to axiomatic approach to probability. Terms related to axiomatic approach to probability. The first term is event. The first term is event. Okay. Event. So before we study the event, we have studied about the experiments, outcomes. Okay. These outcomes are denoted by various types of events. Event means the outcomes in case of axiomatic approach to probability. The various outcomes are denoted by the sets, and these are called events. Events means the occurrence of different outcomes in an experiment are called event. Okay. The occurrence of different outcomes in an experiment are called events. This is the simplified definition of event, the occurrence of different outcomes in an experiment. Okay. For example, we can say event of throwing a die. We can directly say event of throwing a die. Okay. And we denote it by S. Event of throwing a die. And if we denote it by a set, we write 1, 2, 3, 4, 5, 6. Okay. Or we can say event of occurrence of an even number in throwing a die. Event of occurrence of an even number in throwing a die. So how many even numbers are there? There are 2, 4, 6. Okay. The next term. Have you understood the meaning of event?
Yes, sir.
Yes, sir.
Second most important term is sample space. Sample space, this I have written S. Sample space is the set of all possible outcomes associated with a random experiment. Understood? Sample space is the set of all possible outcomes associated with a random experiment or the probabilistic experiment. One example is this: S equals to event of throwing a die. Similarly, we can write the other examples also. I am giving some of the examples of sample space. Like first, and it is always denoted by S. Sample space is denoted by S. If we write S equals to event of tossing a coin, so it is denoted by H T. Okay. So there are only 2 events associated with this experiment. Again, if we write S equals to event of tossing 2 coins, Okay. Event of tossing 2 coins. So 2 heads. 1 head, 1 tail. First coin comes up with tail, second coin comes up with head. Or both the coins come up with tails. Understood? So there will be 4 events associated with the sample space of event of tossing 2 coins. Understood, everyone?
Yes, sir.
Again, if we write event of tossing 3 coins, so how to denote it? Event of tossing 3 coins. So it is first all the 3 comes up with head, or 2 head, 1 tail. 2 head, 1 tail means first coins comes up with head, second coin comes up with head, third with tail. We can name the 3 coins as first, second, third, as they are different coins. Again, head, tail, head, then tail, head, head. Then 2 comes up with tail and 1 with head. So there will be other 2 cases are also there. There will be other 2 cases associated with this. 2 tail, 1 head, or first head, next tails. Then 1, 2, 3, 4, 5, 6, 7. And last one is TTT. There will be 8 outcomes. And we can find the number of outcomes even with using permutation, theory of permutation, as there are 2 possible outcomes for first coin. Either it comes up with head or with tail. For second also there will be 2 outcomes. For third also there will be 2 outcomes. So in all there will be and means principle of multiplication will be used. So there will be total 8 outcomes. So we can count to check how many outcomes can be there. Okay. One more. If we write event of throwing 2 dice. Event of throwing 2 dice. So how many possible outcomes will be there? First die has 6, second also has 6, and the first and second both are thrown together. So total number of outcomes will be how many? 36. Is that clear to you? So first will be 1, 1. Second is 1, 2. Third is 1, 3. 1, 4. 1, 5. 1, 6. There is no need to write all. Right, like this 2, 1, and finally 6, 1, and finally 6, 6. So these types of sets are called sample space, which give all possible outcomes associated with a random experiment. Understood, everyone?
Yes, sir.
A set of all
Yes, sir.
outcomes associated with a random experiment is called sample space. Okay. Then we write E equals to the third term. First, if we write E means an event and S means sample space. So in this theory, if we find the probability, it is denoted by P, probability of an event E. P means probability of an event E. Okay. According to axiomatic approach, probability of an event E is denoted by P, and it will be equal to number of elements in E. We know that this is the cardinal number of a set upon number of elements in S. Okay. By this method, we can easily find the probability. Probability of E equals to number of elements in E upon number of elements in S. Now we know that number of elements in E means variable event always lies between 0. It is always positive, means it must be greater than 0. And it will always be less than number of elements in S. So if we divide all 3 of them with an S, means number of elements in S, 0 upon number of elements will be 0, and NS upon NS will be 1. So probability of an event always lies between 0 to 1. Is that clear to you? So probability of an event always lies between 0 to 1. So this is the simple discussion of axiomatic approach. And in next session, we will discuss how to solve the questions using axiomatic approach to probability. As this session is about to